Welcome back to today's session. So we have learned solving a game with saddle point and games without saddle point. We have solved 2x2 game with formula method. We have solved n cross 2 and 2 cross m problems using graphical method. Now, the last type of problem and the last topic of game theory is dominance property. This property is used whenever we are solving an m cross n game, right? The structure of the problem will be an m cross n game without saddle point. So here, the basic concept that we use is the superior strategies or better strategies or more optimal strategies will always dominate the inferior or suboptimal or non-optimal strategies. See, if at all, for a simple example, let me tell you, if at all you get a job which is 10 to 5 and you are able to earn a salary of 1 lakh is one option, and there is one more option, same 10 to 5 job, you are getting 1.5 lakhs. So what you will do, you will obviously choose the second option, right? Same 10 to 5 but 1.5 lakhs. So it is a dominant option or a superior option. So whenever you have a superior option, inferior options can be ignored. So you need not consider them. That is the basic concept that we use in dominance property type of problem or m cross n type of problems. So here, in such cases of dominance, we reduce the size of the payoff matrix by deleting those strategies which are dominated by others. So as I said in the example, if at all you have an inferior strategy or a strategy that can be dominated, then such strategy is no use. There is no use in retaining that strategy. So you can just delete it, right? That row or that column which is representing a particular strategy can be deleted. So when you delete a row or a column, what happens? The size of the payoff matrix will get reduced. So this is what we call as dominance property. So how does a row dominate another, or how does a column dominate another? So for that, we have three rules, three important rules of dominance property that we are supposed to remember. So the first one is, if all elements of a row, say the kth row, are less than or equal to the corresponding elements of any other row, say rth row, then kth row is dominated by the rth row. See, if any particular row you take, all the elements are less than or equal to corresponding elements of another row, then whichever elements were smaller, that particular row you can delete. Okay? Similarly, with respect to column, the rule says if all the elements of a column, say kth column, are greater than or equal to the corresponding elements of any other column, say rth column, then the kth column is dominated by the rth column. See, in row what we did, whichever was minimum, see, whichever was smaller, right, that row we deleted. Here it is the opposite way. Whichever is greater than or equal to, right, if at all a particular column has its element all greater than the corresponding elements of another column, then those greater elements column can be deleted, right? Dominated rows and columns may be deleted to reduce the size of the payoff matrix, as the optimal strategies will remain uninfected. See, what is the reason that we are deleting the row or column? Does it not change the problem? Might be a doubt that you get. See, whenever we are solving, we are always considering row minima and column maxima, right? So whenever I delete a row which has all its element as minimum, then it might be participating in the row minima, but it will not be the maximum of the row minima. So there is no chance for it to become the max of the row minima. So it will not be a maximum point. Therefore, even if you delete that row, it doesn't matter. Same way in the column. See, all the column maximas are considered. So the maximum most elements are considered. But after the column maximas are calculated, we are supposed to consider the minimum of them. Right? So, from the deleted column, it will not become or it will not be participating in the minimax value. Therefore, even if you delete, it will not cause any problem. That is what this dominance property tells you. Right? See, if at all there is a situation where there is no row dominance or no column dominance, but still the size of the problem has not reduced to either n cross 2 or 2 cross m or 2 cross 2, then what to do? So in that situation, you can take some linear combination of some rows which might dominate a particular row, right? Combination of two rows you can take and compare it with another row and delete the dominated row. Fine. Same thing holds good for the column as well. So this also can be used, but very rarely we get a scenario where we will be using linear combinations. But for you to understand, I will be taking an example problem which considers linear combination also. We will see that also. So this is the only concept with respect to dominance property. If at all you know these three rules, any problem you want, you can solve, which is of type m cross n. I will take three different examples. One example where the problem straight away gets reduced to 2 cross 2. Second example that I will take where I have a linear combination scenario. Third one I will take where it has to be solved using graphical method. Fine. We will take three problems and try to understand. So let me go with the first problem now. The first problem is a 3 cross 3 game. We are supposed to solve it. See, you observe here the third row, right, has the values 5, 1, 6. Compare it with the second row. 5 is less than 6, 1 is less than 2, 6 is less than 7. So all the elements of the third row are less than or equal to corresponding elements of the second row. So what does that mean? Row number 3 is dominated by row number 2. Therefore, there is no problem if at all you delete the third row. So I can just eliminate or delete this third row because it is dominated. Okay. So I am left out with 172, 627. Now when you compare the third column with the first column. See, 2 is greater than 1, 7 is greater than 6. So that means to say third column elements are greater than the first column elements. So third column is dominated by first column. Therefore, you can delete column number 3. So this column gets deleted. Now I am remaining with a problem which is a 2 cross 2 problem. 1762. So when you have a 2 cross 2 problem, you know solving it is very simple. So what are the strategies that I am left out with? 17 is A1, 62 is A2. So when I take 16, it is B1, 72 is B2. So I am left out with A1, A2, B1, B2. So A3, third row was deleted. So A3 strategy will have 0, and because third column was deleted, B3 column will have 0. So now solve the problem using formula method. I will not go in detail. I will straight away tell you A11 is 1, A12 is 7, A21 is 6, A22 is 2. So when I substitute in the P1 formula, I'll get P1 value as 2 by 5. If P1 is 2 by 5, P2 will be 1 minus 2 by 5, which is 3 by 5. So I got P1 value and P2 value. Similarly, substitute the values for Q1. I get the answer to be 1 by 2. If Q1 is half, Q2 will be 1 minus half, which is once again half. So next, find the value of the game. Substitute all these values in the given formula. So you will get 2 minus 42 by minus 10. So it will be minus 40 by minus 10, which is 4. So the value of the game is 4. Optimal strategy for A is A1 with 2 by 5 probability, A2 with 3 by 5 probability. Then optimal strategies for B. B1 with probability half, B2 with probability half. A3 and B3 strategies will not be used because they have probabilities 0. Okay, so this is one problem with respect to dominance property. We will take a second problem now, which is a 4 cross 4 game. 5 minus 10, 9, 0, 6, 7, 8, 1, 8, 7, 15, 1, 3, 4, 1, 4, or 3, 4, minus 1, 4. See here, first row and third row I compare. First row, 5 less than 8, minus 10 less than 7, 9 less than 15, 0 less than 1. So all the elements of the first row are less than equal to third row elements. So I can delete row number 1. So I am left out with 6, 7, 8, 1, 8, 7, 15, 1, 3, 4, minus 1, 4. Now compare the second row with the third row. 3 is less than 8, 4 is less than 7, minus 1 is less than 15, 4 4 is less than 1. No, I have maybe done a small mistake here while copying the problem. This might be something else. This might not be 4, this might be some other value. So that is why row 2 is dominated by row 3. Row 2 is dominated by row 3. I can eliminate row 2. Next, compare the second column and fourth column. 7 greater than 1, 4 greater than equal to 4. So this is dominated. So I can straight away delete column number 2. So I am left out with 8, 15, 1. 3 minus 1, 4. Okay. Still, I take a combination, right? Now I am taking combination of second and third column. See, second column is 15, third column is 1, minus 1 and 4. So I'm using that combination and I'm taking the uh, half values of each, right? Half value of 15 is 7.5, half value of 1 is 0.5, 7.5 plus 0.5 is 8. And similarly, when I take the second row elements, minus 1 and 4, half value of minus 1 is minus 0.5, half value of 4 is 2, minus 0.5 plus 2 is plus 1.5. So the combined values that I get is 8 and 1.5. So when I compare it with the first column, right? First column entries are 8. 8 greater than equal to 8, accepted. 3 greater than equal to 1.5, this is also accepted. So that way, column number 1 is dominated by the combination of second and third column. So first column can be deleted. So I am left out with 15, 1, minus 1 and 4. So apply the formula method and try to solve it. So you will get whichever rows are deleted. First row, second row were deleted, so I get a 0 and 0 for it. First column and second column were deleted, so I get a 0 and 0 for it. I am left out with B3, B4, A3, A4. So substitute those values. A11 is 15, A12 is 1, A21 is minus 1, A22 is 4. So when I apply it in P1, I get P1 value to be 5 by 19. So if P1 is 5 by 19, P2 is 14 by 19. So substitute the values in Q1, I get 3 by 19. If Q1 is 3 by 19, Q2 will be 16 by 19. Okay. Next, find the value of the game. Substitute the values in the formula. You'll get 60 plus 1 by 19. So which will be 61 by 19. Okay. So the optimal strategies, A1 was 0, A2 was 0, A3 is 5 by 19, A4 is 14 by 19. Similarly, optimal strategies for B, 0, B1 0, B2 0, B3 is 3 by 19, B4 is 16 by 19. So this problem is also quite simple. Now coming to the third type of problem or third category of problem where using dominance property you are able to reduce it to 2 cross n and m cross 2 type of problem, and then you will have to apply graphical method. So given problem is a 3 cross 3 problem. The problem is 3 minus 2 4 minus 1 4 2 2 2 6. So straight away compare the third column and the first column. Very simple, 3 less than 4, minus 1 less than 2, 2 less than 6. So the property is satisfied. So first column, column greater than has to be removed, right? So I'll just erase it, sorry. This column gets deleted. Whichever is greater has to get deleted. So I am left out with 3 minus 2 minus 1 4 2 2. Compare here first row and second row. 3 greater than minus 1, but minus 2 is not greater than 4. Compare first row and third row. 3 greater than 2, but minus 2 is not greater than 2. Compare row 2 and row 3. 2 greater than minus 1, but 2 is not greater than 4. So row wise, no change can be done. Maybe have a look at the column, 3 greater than minus 2, but minus 1 is not greater than 4. So combination also cannot be applied because I have one negative here and one negative here. So if I combine these two also, it will not satisfy this. If I combine second row and third row also, first row cannot be dominated. So there is no other option. But the structure of the problem is m cross 2, right? I have m rows, which is 3 rows, and I have 2 columns. So m cross 2 method can be applied. So I can apply graphical method on this. So the points that I've got is 3, minus 2, minus 1, 4, 2 and 2. 3 and minus 2 for A1, minus 1 and 4 for A2, 2 and 2 for A3. Okay. So because it is m cross 2 type of game, upper envelope has to be considered. So I'm highlighting the upper envelope, and when I consider the upper envelope, the lowermost point in the envelope has to be considered. So here you might be observing that both the points are at the same level. So how will you consider which is the lowest point? Fine. That is actually causing a confusion. But you need not worry. If at all both the points are at the same level, look at the coordinate in the upper envelope. See here, this is at a higher level and this is at a lower level. So I am supposed to consider this line. Okay. So in that case, this line has to be considered and this line has to be considered. This will be the point of intersection, which is showing us the minimax value. So when I consider A1 and A3 as the lines, so the coordinates will be 3 and minus 2, then 2 and 2. Okay, 3 minus 2, 2 and 2. Now the problem is a 2 cross 2 problem. Straight away apply the formula method and try to solve it. So A11 is 3, A12 is minus 2, A21 is 2, A22 is 2. So the optimal strategies I was left out with A1 and A3, right? So A1 and A3 we were left out, so A2 is 0. We were left out with B1 and B2, so B3 is a 0. So compute P1. P1 will be 2 minus 2 divided by 3 plus 2 minus 2 plus 2. So which will be a 0. If P1 is 0, P2 must be 1. Because 1 minus P1. 1 minus 0 is 1. So I get P2 as 1. Then calculate Q1. When you substitute the values, you get Q1 as 4 by 5. If Q1 is 4 by 5, Q2 must be 1 minus 4 by 5, which is 1 by 5. Find the value of the game. When you substitute the values, you get 6 plus 4 by 5, which is 10 by 5, which is 2. So the value of the game is 2. The optimal strategies for A, as such, A1 is P1. P1 value was 0, so I get a 0 here. A2 already was a 0, so I get a 0 here. A3 is P2, which is 1. Okay. Optimal strategies for B, Q1 is 4.5, B1 with probability 4.5, 4 by 5, B2 with probability 1 by 5, and B3 we had already decided it to be 0. Right? Isn't it very simple? The problem of dominance property is very simple. See, when you are looking at the video, you might have felt it to be very easy, but when you are actually solving a problem, right, identifying which rows have to be compared or which columns have to be compared, So we'll take some time, right? We'll take some practice. So 2 or 3 problems you solve, as soon as you look at the problem, you'll start realizing, okay, this row is dominating the other, or this column is dominating the other. So it will be very simple, nothing to worry. Only thing is 2 or 3 problems you have to solve. Okay? This completes game theory. In the next session, we are supposed to start off with one more new topic of the same unit called dynamic programming, which does not involve any problems. In dynamic programming, it is only theory. So maybe 2 or 3 sessions at most I will require. So that will complete dynamic programming and unit number 4. Anyhow, thank you for your patient listening. Have a nice time. Enjoy.